All right, so this is problem 6.9.41, and we have the intensity I of light from a light bulb varies inversely as the square of the distance d from the light bulb. And we want to suppose I is 90 when the distance is 5. How much farther would it be to a point where the intensity is 40? So now this problem is a little interesting because this how much farther would it be? We're not actually just, they're not actually just giving us a value that we're going to plug in. We actually have to think about what that means. Okay, so let's go ahead and start though by finding the equation of variation. And so we have I here is equal to k over d squared. Now the reason that we have that is because the intensity varies inversely, and remember that inverse variation is division, and it says as the square of d. And so k over d squared would be that inverse variation form. Okay. All right, so now they're giving us some values here, some values for I and D that we can go ahead and plug in to find the K so that we can get the equation of variation. So let's go ahead and take the 90, plug that in for I, and we'll go ahead and take 5 and plug that in for the D. And so really we're looking at, K over 25 equal to 90, okay? All right, so we want to solve for k, so we're going to multiply both sides by 25 to clear the fraction. So we have k here is equal to 2250. Now, this we can plug back in, and we actually have the equation of variation. So we have 2250 over d squared. Now, that is not what they asked us for, but this is an important step on our journey to finding what they asked us for. So this is the equation of variation. All right, so now we have to think about this. So they ask how much farther would it be to a point where the intensity is I. So they're giving us a value for I, and they want us to find a distance d, but the distance d is going to be farther, than 5. So the 5 is involved. So the question is, how much farther? And if we let x be the amount that's beyond the 5, then we would actually have to add 5 to it. This right here would represent how much farther. Okay. So I'm actually going to plug that x plus 5 in for the d there at the same time that I plug 40 in for the I, and then just solve that. Okay. All right, so let's see if I have scratch paper. I do. Yay. So we're looking at I is equal to 2250 over x plus 5 quantity squared. Excuse me, I was going to plug in 40 for the I. Okay. All right, so now we're just solving. We can cross multiply here. And so this is 40 times x plus 5 quantity squared equal to 2250. Now you might look at that and say, well, okay, we need to, write this in the expanded form, FOIL it out, set it to 0, do that whole thing. But we actually don't need to. There's a shortcut here. We can use the principle of square roots to solve this. So if we isolate the x plus 5 quantity squared, then, the 2250 divided by 40, let's find what that is. And we get 56.25. Okay. All right, so now the reason I didn't do the whole foiling setting to 0 thing here with this quadratic is I recognize I have a quantity squared, and in this form I can actually use the principle of square roots that says I can take a square root of both sides and out pops my x plus 5. Okay, so we have x plus 5 then equal to plus or minus the square root of 56.25, which is 7.5. Okay, so we're going to continue to solve. Let's subtract 5 from both sides. We have x is negative 5 plus or minus 7.5. And that's two different things, right? So that is negative 5 plus 7.5, and it's also negative 5 minus 7.5. Now this is negative, and that doesn't make any sense because we're talking about distance in this problem. and this one is 2.5. So the answer here would be it's 2.5 meters farther for the situation that they were talking about, the intensity of 40. Okay, and that's it in this problem.